So technically, there are two ways of how we are getting the data. So there is a web crawler which is set up to crawl different sites, and then there is a custom document submission mechanism, which uses the Workbench client API to feed the documents into the Workbench server, and that leads us to the second stage of content processing, where we do a lot of language processing, text analytics, and a couple of examples you see on the screen are file conversion. So, for example, like if I have my content in Word, PDF, I first want to be able to extract that text, because then I will be doing analysis on the text. Content categorization, which will taxonomize my content, identify topics and particular products. When I'm showing the example of Samsung 32-inch TV, so we want to be able to classify documents that this document is talking about Samsung, within Samsung it's talking about 32-inch TVs, 40 to 40-inch TVs, and so forth. And obviously the sentiment, which identifies sentiment for the whole document. Once all this analysis has been done, everything is fed into a search server, and the search server is the one that drives my query infrastructure that I was showing you for plotting the charts. There is a small database which keeps track of users and groups, that kind of information. And all this together fits into a web gateway, which is the data review part, where the analyst is looking at the data. So the analyst is completely shielded from the back-end technical aspects of the view. So now we'll look at each of these states one by one, what's happening exactly within those states. The first is data collection. The goal here is very simply stated, gather documents, but this could be the most complicated part of all the 4 steps. So here our goal is we are getting documents from different sources. The enterprise could have a lot of content within their own content management systems, their own document repositories, which are basically customer feedbacks, complaints database, things of that sort. So they need to create a mechanism to extract the content and feed it into the Workbench server using the Workbench client. If you don't have data, you could use external data aggregators like BoardReader, who sort of crawl the whole internet, and then they provide you content for last X number of years, and you can explicitly license content from these data aggregators. You can choose to, if you're not a large enterprise and you know that you only want to track only specific forums and sites, you can use the crawler. So in case of crawler, because you could potentially be crawling substantial websites, substantial part of the internet, there are a couple of things you need to be aware of in terms of scalability. Like the crawler is primarily IO bound job, because you are downloading lots and lots of stuff. So the crawler is typically, it has to be multi-threaded because it's not CPU bound. You have multiple threads so that they can download as much data as possible. As you are downloading the data, you need to be aware of a couple of complications there. You don't want to follow duplicate links. Many times, many links can link to the same pages. You want to be polite. You don't want to bombard somebody's site. Otherwise, the site administrator will block you. You don't want to download any unusable content like image files, movie files. They don't contain any text, so you are not interested in crawling those. So these are some of the salient features of the crawler we provide, but generally these are the features that should be ideally presented in our crawler. Nowadays, there is a lot of JavaScripting, Ajax. So Flash, you want the crawler to be able to pass through those objects to follow different links. And obviously some of the sites could be subscription based, so you want cookie support so that you can explicitly specify username, password to go into proprietary sites and get the results out of those. And then also now you have access to all the APIs from Google Search, Twitter, Facebook, all these proprietary online social media sites who provide their APIs, and we can integrate into your product. And this is all this you are seeing is already done into the crawler that we provide. So this is a screenshot of the product. I'm not going to go into the detail because there is not much to show here. So typically you set up a seed URL. Here I am setting the seed URL is go to www.sas.com and crawl all the pages below under that website. So in this case, at the end I end up crawling the whole of SAS website. So you can also set explicit limits, like you want to set that I am not interested in beyond 100,000 files, or you want to set a limit based on the amount of data you want to crawl, how many megabytes and things like that. So once the data has been crawled, the next step is data conversion and annotation. The first thing within data conversion is we are passing the content, and the next thing is normalizing the documents into a standard schema. When I am downloading content from different sources, they can be formatted in different ways. So one step, example of normalizing is can I separate out the title of a document from the content of the document, because then I want to do the analysis on the content. The next step is annotation, which is the process of sentiment analysis and content categorization. And let's go into the details of sentiment analysis and content categorization. For sentiment analysis, as I mentioned, we are using a hybrid approach. The primary goal here is we want to track sentiment not only for the whole entity or the organization. We also want to do more final grained sentiment analysis, which could be specific business attributes. So if I'm a large corporation, one of the business attributes I might want to track is corporate reputation, or like best places to work for. If I'm trying to analyze that my product has and I want to track these 5 primary features that are most important. So we use a hybrid model. What it means is there is a statistical model which sort of given a corpus, some training data, which learns the set of useful key indicators which indicate positive and negative. And then I enhance that model by adding activities. So here the idea is there is a configuration studio tool where you define your rules, and all these rules feed into the analysis which you saw the way we plotted things into the workbench. So to give you a concrete example here, here is what I am doing. So I don't have a statistical model, but I have already gone ahead and created some positive negative keywords. So in this case I am showing you a very simple example where the terms are purely terms. They are not complex rules. So when somebody says positive or negative things, usually they are mentioning terms like, so in this case we are looking at positive terms. Some might say awesome, great value for money, things of that sort. Or negative could be atrocious, piece of crap. So these can be learned statistically from, if you have a corpus of positive, negative documents, this can be learned completely automatically statistically. And once you have learned them, you can go and edit those lists, and you can further narrow them down into different kinds of rules. And we'll see some examples of rules. So here, for example, we were looking at TV data, and I am trying to do sentiment analysis across a lot of different brands. So for Sony, what I've done is I've gone ahead and listed all the Sony models, because whenever somebody mentions a particular model number, they're also talking about Sony in general. So this is how I identify Sony. The next thing is we can associate that TV has following features, which could be things like design, picture adjustment, performance, color accuracy, sound, power consumption, things like that. And then if I look at any one of them, so picture adjustment, picture adjustment. So whenever somebody is talking about picture quality, image, quality of the picture, then they are talking about the picture quality. So till now I have been showing you very simple rules, but you could write complex rules. So now